We have the higher Heinamann Maths Essential Skills exercises. This is exercise 4, factorizing. This is an important one. You need to be able to do this in your sleep if you're doing higher maths. So let's go through some examples. 3ab squared and 9ab, want to factorize that, put it back into brackets or back into a bracket. There's only two terms. There's no number term on the end. So I'm going to look for a common factor first of all, which we should do with any of these questions, to be fair. Always look for a common factor first. So 3 goes into 3 and 9. They've got an a in both terms, they've got a b in both terms. So I'm going to take out 3ab as a common factor. Then 3ab multiplied by what will make 3ab squared. Well, there's a b squared term, so we need b times b to make b squared. 3a we already have. And then 3ab multiplied by what makes 9ab? Well, that's just 3. So we have b plus 3 in the bracket. Example B, x squared plus 5x plus 6. Quick look for a common factor. No common factor. So we have a straightforward trinomial. Both positive terms should hopefully be dead easy. Remember, we're looking for a pair of numbers that multiply together to make 6. So we may have a 3 and a 2 or a 6 and a 1 at the end of the bracket. And I'm sure you've been told they need to add together to make 5, which is technically correct. What can lead to misunderstanding when doing the slightly trickier ones. Okay, so this 5x comes from the outside and inside terms are multiplying out. So we've got 3x here, 3 times x and x times 2. Do they add together to make 5x? Yes, they do. So we've got it correct. If we add the 6 and the 1 in here, we could get 6x and x, which if we have, we could also make 5x. However, it would have to be a negative 1, and when we multiply the negative 1 by the 6, we wouldn't get positive 6. So in this case, it is x plus 3, x plus 2. So I'm going to go for a similar example to B there, but I'm going to do it with a coefficient of the squared term larger than 1. So in other words, more than just 1x squared or 1p squared. So here I have 5p squared. So again, look for a common factor. We don't have one. So to get this 5p squared term, I'll need to do 5p times p. So I'm going with that for the start of my brackets. The end terms, or the last term, the 6, I'm going to ignore the minus sign just now, would come from this term multiplied by this term. So I'm going to try 1 and 6. Now this is what I was talking about in this example. If we're thinking, if I've got a 1 and a 6 can add together to make negative 13, that's not technically right here. This negative 13 needs to come from what we get when we do this multiplied by this. So here, this will give 30p, this will give 1p. There's no way I can get negative 13p with a 30 and a 1. So we have that wrong. So we need to try a different combination. I'm just going to swap the numbers around. Sorry, somebody just came into my room now. I was speaking to them, so I'll go from where I thought I was. So I'm going to swap them around. So I'm going to put the 6 there and the 1 there. So this will give 5p and this will give 6p. Remember, we're trying to make negative 13. So with a 5 and a 6, we're not getting negative 13. And the 6 times the 1 would definitely be the 6. The 5p times the p would definitely be 5p squared. So we have to think of another way of making 6. So I am going to go for 2 and a 3, or 3 and a 2. Let's go 3 and 2. So 10p, 3p. So starting to look good now. If I've got a 10 and a 3, I can definitely make negative 13. It would need to be negative here, negative here. So where did the negative 3p came from? That came from the 3 multiplied by p, so that would have to be negative there. 5p times 2, and I want negative 10p, so it would have to be negative 2. So it looks as though I've done it correctly. but I need to quickly check that the last two terms multiplied together make -6. Unfortunately, they don't. So it looks as though we have it right, but in fact we don't. So I am just going to hit the undo button and leave that. Just going to swap the numbers around and hope that it's going to come out right this time. Otherwise, we have some problems. So 2 times p, 2p, 5p times 3, 15p. So if I've got a 15 and a 2 and I want -13, it needs to be -15p. So that would come from 5p multiplied by -3. And 2p would come from +2 multiplied by p. Quick check, 2 times -3 is indeed -6. So that is factorising when we have a coefficient of greater than 1 for the squared term. What you may have found last year, your teachers may have had a little grid here, and you'd write down your 5p and your p, and put your 1 and your 6, and your 6 and your 1, and your 2 and your 3, and your 3 and your 2. And you do a lot of crossing over and multiplying and things. I just find when pupils do that, they don't really understand what's going on, but if they put in a bit of time and just kind of working it out and actually understanding that this comes from these two terms, then there's less problems, people understand it better, they perform better, they're able to get more questions right, they're able to do it quicker. So that's why I don't bother with this. If you think something looks like that, you can also write that table that way as well. So again, you put your 1, your 6, your 6, your 1, your 2, your 3, your 3, your 2, you do all the crossing over stuff. Okay, so again, I would just suggest actually just going with that, get your pencil out and the rubber, work through it. You'll find after you've done about 10 or 15 of them, you can do it in your head. Whereas you could do 100 of those and you still wouldn't really understand what's going on. Right, I'm going to go into part C, just rub this out. So 20 subtract 15a subtract 5a squared. I'm going to take out a common factor of -5 here. So -5 multiplied by a squared at 3a subtract 4 would give our original terms. And here it's going to be a and a at the front. Need to multiply to make -4, so I'm trying 4 and -1. Again, this 3a term will come from 4 times a and a times -1, which is 4a subtract a. So that works out. So that's that one done. Part D is the difference of two squares. So we should be able to spot difference of two squares. Basically, we have a squared term and just a number term. There's no y term in the middle. That's how we spot them. So the difference of two squares, if we have it in the form a squared minus b squared, which we do here because 81 is 9 squared, we should remember that that is a plus b multiplied by a minus b. So here, as I said, y squared minus 9 squared, so it's y plus 9, y minus 9, just using this as a template. E, again, always look for a common factor, so a common factor of 2 here, so it's 2 bracket 36 minus t squared. So that's 6 squared minus t squared in the bracket, so 6 minus t, 6 plus t. I could write 6 plus t, 6 minus t, because we're multiplying, the order's not important. So common factor first, then difference of two squares. No, we can't, I see pupils do this a lot, we cannot just think, I'm going to put the t squared at the front, because it's negative t squared here. If you had written t minus 6, t plus 6, and you multiply it back out, you will not get what you started with. You get the negative of it, you get 2t squared minus 72. So you can't randomly be making the t positive and the 6 negative here. It doesn't work. And f t to the 4 subtract 1. I know t squared, all squared, will be t to the 4. So I can write that as t squared minus 1, t squared plus 1. And t squared minus 1 I can factorize again using difference of two squares. It's like t squared minus 1 squared, so t plus 1, t minus 1. This bracket doesn't factorize. Assuming National 5 knowledge is quite good, we could have a look at b squared minus 4ac and we'll just show that there's no real roots, which basically means we can't factorize the bracket. So t plus 1, t minus 1, t squared plus 1 at the end. Right, have a go at Essential Skills Exercise 4, which is on page 324.